we go, guys. More trigonometry. I love it. I know you love it. We all love it. Super fun. I'm going to go through these problems. Follow along. Try your best. Make sure you're working, trying your hardest. Give the old geometry. Okay, time to get tricky with it. Here we go. Find the value of x. It's helpful to write this at the top of everything you're doing until you're very good at it. I'm going to start slow, but I'm going to start skipping steps later on. But here's as slow as we can go. You figure out which angle you're going to work on, the 55. You figure out how are the two sides you're going to work on related to that angle. This is opposite my 55, and this is my hypotenuse. OH is a sine problem. That means that the sine of theta equals opposite over hypotenuse. That's what the SO part of SOHCAHTOA tells us. And so, before we go, we got to find the ratio. The sine of 55 degrees equals opposite x over hypotenuse 59. That is how we set this up. If x is up high, all you got to do is multiply. Get it right your first try. So this is the exact answer. We're going to type that into our calculator. 59 times the sine of 55. And I get 48 point blah, 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 blah. And that's what it ends up being. Perfect. Killed it. Nailed it. Moving on. The line of sight from a small boat to the light at the top of a 35-foot lighthouse built on a 25-foot on a cliff 25 feet above the water makes a 25-degree angle with the water. So we got a triangle going on. We basically have a 25-degree angle with the water. We have 35 plus 25, so this side is 60. And it says to the nearest foot. What is the horizontal distance? Horizontal distance, that's the horizontal distance to the light. That has to be a horizontal number. This is actual distance, this is height, this is horizontal distance. So this is our triangle. So this is going to be opposite, adjacent, that's the TOA part of SOHCAHTOA. So that's the tangent of theta equals opposite over adjacent. So for this question, it's going to be the tangent of 25 equals 60 over x. How did I get 60? I added the lighthouse plus the cliff to get the total height 60. If x is down low, they switch places, you know. So 60 over tan 25, they are going to switch places, you know. This is the exact answer. We type that in. 60 over tan 25 is 128.67, which rounds to 129. Let's go. Find the measure of x in the right triangle. Love it. X is the angle this time. So there's the angle we're going to use. 8 is the adjacent side, and 21 is the hypotenuse. That's the ka part, so TOA. That's the ka part of SOHCAHTOA. The cosine of theta equals adjacent over hypotenuse. So in this question, the cosine of x equals 8 over 21. How do you undo a cosine? You do inverse cosine. And if I do inverse cosine of one side, I have to do inverse cosine of the other side. So x equals, right, inverse cosine cancels out cosine. The inverse cosine of 8 over 21. That's the exact answer, but we have to type that in. Inverse cosine 8 over 21 is 67.6. Let's go, 67.6. And that is how big that angle is. Killing it. Cruising along. What is the value of x? We got a triangle here. We're working on the 20. 9 is opposite the 20. X is adjacent to the 20. So opposite over adjacent, that's the SOHCAHTOA. That's the TOA part of SOHCAHTOA. So the tangent of theta equals opposite over adjacent. That's what this tells us. The tangent of 20 equals 9 over x. If x is down low, they switch places, you know. Getting tricky with it. Let's go. So what happens? We get 9 over tan 20. Type that in. 9 over tan 20. And I get 24.7. There we go, 24.7. Love it. They didn't actually give like specific rounding instructions on some of these, but since they're multiple choice, we go by the way that they're rounded in the question. So 24.7 is what we're looking for. Which answer is closest to the value of x? Here's the angle we're working on. This is the opposite side. This is the adjacent side. We just talked about this, guys. That's TOA. So I'm going to skip some of the steps and go straight to the setup. The setup would be the tangent of x equals opposite over adjacent. It's the, how do we undo tangent? We apply an inverse tangent. So the tangent cancels out over here, but we have to hit the other side with an inverse tangent to do that. So this is the answer, but if we're going to round it, we do the inverse tangent of 19 over 11, and I get 59.93. This is the closest answer to 59.93. Loving it, killing it, moving along. Write the ratios for sine A and cosine A. Write the what? The ratios. We're not solving for angle A. It doesn't say that. It's just what are the ratios. So for angle A, sine would be opposite. So the sine of angle A would be opposite 3 over hypotenuse 5. So sine of angle A would be 3/5. Moving on to the cosine of angle A. Cosine is adjacent hypotenuse. The cosine of angle A equals adjacent 4 hypotenuse 5. So choice A here is the one that has those correct for us. Love it. Moving on. What is cosine B for the triangle shown? Again, when I say what is cosine B equals and B equals are very different things. I'm asking you for the cosine of B, not angle B. Cosine is adjacent over hypotenuse. So the cosine of angle B is going to equal adjacent 8 over hypotenuse 17. That is the cosine ratio for angle B, which is what it's asking for there. So that's the cosine of angle B, my friends. 8 over 17. All right, keeping the ball rolling. Maria, Abby, and Tanishka decide to make a right triangle with the tips of their noses. So we have 3 people. They're making a right triangle with their noses. Nice. It says Maria is in the top right. And there was a picture with it. I deleted it, but just try to envision 3 people at 3 vertices. We have Maria at the top right. We have Abby at the bottom right and Tanishka in the top left. Maria's nose is at the right angle. So I put Maria top right as a right angle. The vertex at Tanishka's nose is 50 degrees. Tanishka knows, Tanishka knows she's 10 feet from Abby. So the distance from Tanishka to Abby is 10 feet. How far to the nearest thousandths is Maria from Abby? That would be this distance. So this is a pretty straightforward trig problem. We have a 50-degree angle. This is opposite hypotenuse. That's the so part of SOHCAHTOA. So that's going to be the sine of 50 equals opposite over hypotenuse. If x is up high, all you gotta do is multiply. Get it right your first try. Now we got to type that in, 10 times the sine of 50. And it says round to the nearest thousandths. You got to be so careful. If you leave it as 7.66, what does it look like you round it to? That looks like the nearest hundredth. If it says round to the nearest thousandths, you better have a digit all the way to the nearest thousandths. So 7.660 is what you have to type in. And I even gave you a hint. For instance, this would have to round to 5.80. You have to write the 0 as a placeholder. One of the acute angles of a right triangle is 10 degrees. Right triangle, one of the acute angles is 10. That means the other one's 80. The hypotenuse is 82. What is the size difference for the 2 legs of the triangles? You got to do this correctly. Use your calculators wisely. So I need to know how long the 2 sides are. And I know that this is going to be the bigger side. How do I know that? 80 is bigger, and 80 degrees is going to produce a bigger side than 10 degrees. It says, what is the size difference for the 2 legs? So I need to do y minus x. That would be the size difference. So let's get this going. We got to solve for these independently. I'm going to solve for x and solve for y using my 10-degree angle. 10 degrees, x is opposite, and this is hypotenuse. So to solve for x, I'm going to say the sine of 10 equals opposite over hypotenuse. So x equals 82 times the sine of 10. And I'm going to leave it like that. They did not say solve for x. There's no reason to do anything with that. Just leave it alone. Then I'm going to solve for y. Y, still going to use my 10-degree angle. The y is adjacent, and we have the hypotenuse. So the cosine of y equals, the cosine of 10 equals adjacent over hypotenuse. If y is up high, all you got to do is multiply. And I messed up, dang it. It's going to be y over 82. Hopefully you caught that. So y equals 82 times the cosine of 10. And remember, we can tell that this is the bigger one. But we're going to type this into our calculator. And I'm going to type in 82 cosine 10 minus 82 sine 10. So we're doing y minus x, 82 cosine 10 minus 82 sine 10. I'm going to type it exactly like that. And I get 66. We're going to the nearest thousandths, 66.515. And that is my answer there. Boom. Loving it. We type it in exactly like we wrote it. Make sure you get that right. Do not type this in, round it. Type this in, round it, and then subtract two rounded numbers. That's not good math. We do good math in here. This is good math. Challenge question. This is really tough. Maybe a little unfair. I don't know. Somebody will get this, I bet. A right triangle. Love it already. Right triangle has a short leg of 15 and an acute angle that measures 65. It's already tough. Why did I put the 15 and the 65 there? Could I have done this? What if I put the 65 here? Well, now the 15 has to go there. How do I know that? They said 15 is the short leg. Well, if one angle, so forget the 15 for a second. If we know that that is 65, isn't the other angle going to be 25? 25 is smaller than 65. 25 has to produce your short leg. So the side across from 25 has to be my 15 if the short leg is going to be 15. Which of the following would not give you a correct length of the hypotenuse? This is just you need to understand there's more than one way to do a problem. I already marked it. You can tell all of them are correct. I'm going to go through each scenario just so you can see how it works. So I'm going to get rid of this. I could have drawn it like this, but we're not going to use this one here. So we have the 65, the 25, and what's the question we're actually asking for? The hypotenuse. I'm going to call that x, and there's lots of ways we could do it. Let's get this done. First, the most obvious way is that you could say the sine of 25 equals opposite over hypotenuse. If x is down low, they switch places, you know. So that would be 15 over sine 25. That is one version of this answer. Alternatively, focus on the 65. Now we could say the cosine of 65 equals 15 over x. If x is up high, all you got to do is, x is not down up high, it's down low. If x is down low, they switch places, you know. You got to get tricky with it. That is a second version of this answer. A third version would involve us finding this side. I'm going to call it y. So I could find y using the 25. I'll switch colors just for y'all. There we go, we'll use that. So I could say the tangent of 25 equals 15 over y. If y is down low, they switch places, you know. So that'd be 15 over tangent 25. Now that's how long this side is. But if I wanted x, wouldn't x equal the square root of 15 squared plus 15 over tan 25 squared? Isn't that Pythagorean theorem? A squared plus b squared equals c squared. So one way you could do it is to get this side using tangent and then hit it with a Pythagorean theorem. That is going to produce the same answer. And then finally, we can find y using the 65. So could I say tangent of 65 equals y over 15? If y is up high, you multiply. So y would equal 15 times the tangent of 65. Is that another solution for y? Yes, but y is not what we're looking for. Then we would hit it with the Pythagorean theorem. X would equal the square root of 15 squared plus 15 tan 65 squared. And that is another solution. Nailed it. So that means all of these work. Let me show you something here. One of the ways that you could do this question, I'm going to show you in my calculator. All right, take a look. Take a look, my friends. So here's my calculator. So our first one was 15 over the sine of 25. 15 over the sine of 25. Yes? 15 over the sine of 25. I hit enter. That is x. That was the first way we did it. That's the most obvious way to do it. That's our answer. One way you could have done this is once you've established a known answer, could you then type in all the other choices and see if any or all of them match? 15 over the cosine of 65. Same exact answer. Type in the third choice, the square root of 15 squared plus, make sure you do parentheses here, 15 times the tangent of 65 squared. Same exact answer. And then finally, the square root of 15 squared plus, make sure you do parentheses, 15 over tangent 25 squared. That was the other one we did. Same exact answer. So you get the same exact answer every single time, my friends. That's what it looks like. That's what that looks like. That's what I look like. Hi, friends. I never show my face. Love y'all. All right. Let's keep going here. Yes. Oh, gosh. Oh, gosh. Where are we? Here. Sorry about that. All right. So we're looking at this, and we keep the ball rolling. But that's all the different ways you could do that. All right. Number 11. A surveyor is 85 meters from a bridge. The angle of elevation to the top of the bridge is 35 degrees. The surveyor's instrument is 1.42 meters above the ground. Find the height of the bridge to the nearest hundredth. Angle of elevation is how many degrees above a horizontal line. But this is a little bit interesting. So we're talking about an angle of elevation triangle. It's going to look something like this. So we got this angle of elevation triangle. Boom. The surveyor is 85 meters from the bridge. 85 meters from the bridge. The angle of elevation to the top of the bridge is 35. Angle of elevation is how many degrees above a horizontal line you are. The surveyor's instrument is 1.42 meters above the ground. That does matter. So if the instrument we're using to measure is starting 1.42 meters above the ground. So we are going to solve for this number. Let's do that first. So the people that miss this are going to forget about that number. We're going to do that in a second. But right now, ignore that. Just focus on this triangle. And this triangle tells us that the tangent of 35 equals opposite over adjacent. So if x is up high, all you got to do is multiply. This equals this spot. But how find the height of the bridge? The height of the bridge starts here and goes to the top. So the height of the bridge is going to be x plus 1.42. We're not starting on level ground. Our instrument is not in the ground. It's not at the surface of the ground. Our instrument is above the ground. So our instrument that's measuring this is above the ground. And we have to account for that by adding its starting height. So in our calculator, we're going to type 85 tan 35 plus 1.42. 85 tan 35 plus 1.42. And I get 60.94 if we're rounding to the nearest hundredth. Woo! So don't forget that 1.42. All right, another question. An airplane loses 2,000 feet of altitude for every 15,000 feet it travels horizontally. Guys, we're working on right triangles. What does that look like? 15,000 feet horizontally, 2,000 feet of altitude. Altitude is a vertical number. So this is what they're talking about, okay? Find the plane's angle of depression. Where's an angle of depression? Angle of depression is the angle below a horizontal line. This is not an angle of depression or elevation. This is an angle of depression, the one I marked. So that's what we're looking for. What is the angle of depression? What is the number of degrees below the horizontal line? So this would be a tangent question. The tangent of x equals opposite over adjacent. And if x is the angle, we have to do inverse tangent. Oopsie. Inverse tangent of opposite over adjacent. And that's what I'm going to type into my calculator. Could I actually just type in 2 over 15? Yeah, you can type in the reduced number. It's going to be the same answer, I promise. Inverse tangent of 2,000 over 15,000 is going to come out to 7.595. Nailed it. Love it. Super awesome. Oh, that's all? Dang it. Well, I was hoping there'd be more. Okay. Well, if that wasn't enough trig for you, you just wait till next time. Whoo! The next lesson is so fun. Oh, and that's even the bell. All right, guys, I'll see you next time.